We're going to go over the example for beam deflection. And so the number we're getting in this example is going to tell us if we have this beam and we put a certain amount of force onto that beam, how much will it bend down in the middle? So how much will it deflect? Some of the things that we need to know to be able to do the formula we have in the table here, we have to know what material the beam is made out of. In this case, it's a wood beam. It is a Douglas fir tree is the type of wood that the beam comes from. And the material of the beam is directly related to the modulus of elasticity. And so this number, modulus of elasticity, in this case is a given number for Douglas fir. All right? And so dependent upon the material, the modulus of elasticity for the beam would change. Moment of inertia has to do with the shape of the beam, the cross-sectional shape. So moment of inertia is dependent upon the shape. Modulus of elasticity is dependent upon the material. We also need to know the length of the beam, so we have that here. And then we have to know how much force we're going to be putting down on the beam. And if we have all of those things, or we can find them, we can calculate how much the beam will deflect. If we look at our formula sheet here, we have several formulas for beams. We are going to be using the first formula here because we're putting a load on the center of the beam. All right, and so here's our formula. Delta max, or change max, is equal to the force on the beam times the length of the beam cubed divided by 48 modulus of elasticity times the moment of inertia. And so we'll go ahead and write that formula. Delta max is equal to the load, or the force on the beam, times the length of the beam cubed divided by 48, a constant number in our formula, times the modulus of elasticity times the moment of inertia. So if we go through and calculate, plug in our numbers, P 250 times the length of our beam. We need the length to be in inches, not feet. And so 12 feet, there's 12 inches in a foot. So 12 times 12, 144 is the number of inches we get. So 144, we will cube that number, divided by 48, a constant number, modulus of elasticity, (1,800,000) pounds per square inch, times the moment of inertia, which is 20.8. So we go ahead and solve here. So I usually do the top and then the bottom. 144 times 144 times 144. So then I'll multiply that number by 250. That will give us the top part of our formula. 746496000. The bottom part of our formula, 48 times 1800000 times 20.8. We get 17971200000. So we divide those two numbers, 746 496,000 divided by 1,797,12,0000, and we get 0.42 inches. And so what we're saying here is if we have a beam, a wooden beam that's made out of Douglas fir, a type of tree that has a cross-sectional moment of inertia of 20.8, and we put 250 pounds on the middle of it, that beam is going to sag in the middle 0.42 inches. So almost a half an inch. It's going to come down. And that also has to do with the length of the beam being 12 feet. So that's how you calculate beam deflection.